All right, everybody, hello and welcome back. Today what we're going to do is we are going to talk about the unit circle. So the unit circle is a tool that is used for trigonometric functions. All right, what we're going to do is we use this tool to help develop our understanding, and the reason we do it is because of what the unit circle is. It is a circle where the radius is 1 unit. All right, so those trig functions we're talking about, you've probably seen before. They're going to be sine, cosine, and tangent. And essentially what we're going to do using this unit circle is develop our understanding of how these functions are going to work. All right, so technically what the unit circle is, if you could picture the coordinate plane, the unit circle is a circle that is centered at the origin, just like this. And the reason we do this is because each of the radii from here is only 1. And what that allows us to do is find some specific values where we can do calculations and essentially, learn about our trig functions. So in order to do that, we're going to talk about what we call radians. Radians are different ways to measure, different unit to measure the angle of a circle, or the angle in general. So the way I think about it is like inches and centimeters measure the same thing, but they're different units. So are radians and degrees. They measure the exact same thing. All right, so this is our unit circle. Again, this is just the zoomed in version of what we have right here. And to kind of define what a radian is, I'm going to first draw the beginning part of my angle. All right, and then a radian is essentially an angle like this one, where the length on the side here is the same length as our radius. All right, so that means that this length here is the same length as this one. All right, that is what a radian is. So if we take our entire circle here, and you know what, I'll keep that last one in there. We have 1 radian, then we have 2 radians, then we have 3 radians, and there's a little bit extra there. And again, I'm estimating, I'm eyeballing here, but I do know how this should end up looking at the end. So I have a little bit of insider information that we're going to talk about in a second. So there are 3 radians, so this is 1 here. This would be 2 radians. This would be 3 radians. And we keep going from there, and we have 4, 5, 6, and I'll redo that last one so it looks a little bit nicer for us. All right, so again, these aren't perfect, but essentially the idea is each one of our sections of the circumference is going to be 1 radius value. Now, if you notice, we've got a little bit extra right here. All right, and the reason that is because the unit circle, or any circle for that matter, is 2 pi radians. So just like the circle is typically 360 degrees, it is 2 pi radians. And 2 pi, well, if we estimate pi to be 3.14, 2 times 3.14 is 6.28, which kind of accounts for this little bit of extra right here. All right, so radians are just other ways that we measure degrees. We are going to use this to essentially find some values on our unit circle using sine, cosine, and tangent. All right, so in order to do that, we need to think about a few things. These are what we call our quadrantal angles. All right, and so just to build our understanding from here, an entire circle is 360 degrees. But as we just mentioned, it is also 2 pi radians. Well, knowing what we know, knowing that 180 is half of 360, then that means that we should be able to figure out that half of a circle, or 180 degrees, is going to be pi radians. And then we can fill everything else in from there. So obviously we've got 0 degrees is equal to 0 radians. Similarly, if we think about how 270 is directly between 360 and 180, then that means the radian measurement should be directly between 2 pi radians and pi radians, and that is going to be 3 pi over 2 radians, and then we have the same idea down here. If 0 degrees is 0 radians, 180 degrees is 1 pi radians, and that means 90 degrees is half of that, or pi over 2 radians. Okay, so just to go back to our unit circle here, we have our angle. It starts right there. That's 0 radians all the way around. One full circle is 360 degrees, or 2 pi radians. All right, half of a circle, which is our left side over here. So we're talking about the angle that would open up and create a straight line, is going to be pi radians. Then we fill everything else in from there. Half of that would be pi over 2, which is our 90 degrees. And then directly between pi and 2 pi is going to be our 3 pi over 2. All right, and we actually do have some more information that we're going to talk about, and it's specifically going to be different coordinate values on the circle here. Now, we know that because this is the unit circle, it's called the unit circle because the radius is 1 unit, then the coordinates for this point right here are going to be 1, 0. The coordinates for the point right there are going to be 0, 1. On our left side here, we are going to have 0, -1, and then down here, we are going to have 0, -1, which actually, that means this one, excuse me, I wrote my y where my x should be. This one all the way on the left should be -1, 0. All right, so we're going to use this idea, and we are going to start filling in some coordinates on other areas of the unit circle using our trigonometric functions of sine, cosine, and tangent. All right, so before we get into that, what I really want to cover today is how we can convert between degrees and radians. All right, so in order to do that, we need to think about the basis for how any conversions work. Essentially, what we want to do is we want to take our unit, which in this case is degrees, and we are going to multiply by something that is equal to 1. The reason we're doing that is because we don't want the value of our original angle to change. We just want it to change units. So the value should always be equal to 60 degrees. So that means, I'm going to write this as a fraction, I'm going to multiply by another fraction where our top and bottom need to be equal to each other. And the reason that is if you divide something by something that is equal to, you should get 1. Now, the important role we're going to talk about is what goes where. I want to cancel out my degrees. Well, in order for something to cancel in a fraction, we need to have it in the numerator and denominator. So I am going to put 360 degrees in my denominator. All right, now I need to think about, okay, let's switch units to go from degrees to radians. 360 degrees is equivalent to 2 pi radians. All right, and the way that this works is we multiply across, and we will get 120. Technically, we've got a pi, we've got a degree symbol, and then it says radians as well. And then our denominator, we just have 360 degrees. Well, the reason we did this is because now we have degrees in numerators and denominators, so it can cancel out. So we are left with 120 pi divided by 360 radians. All we have to do left is simplify this fraction. 120 divided by 360 is really going to be equal to 1 over 3. So we have 1 pi over 3 radians is equivalent to 60 degrees. Well, let's go back up to the top. If we're looking at this unit circle, we talked about how we're all aware that this is 90 degrees. Well, 60 should be somewhere in between. All right, and if we look at the radian measurement right there, it's pi over 2. So 90 degrees, or this angle, is pi over 2 radians. Well, we need something a little bit less than that, and in that case, it would be pi over 3. So using our unit circle, the image we've drawn, it kind of checks out with what we were able to convert over on the other side. Now, some of you might have noticed that this might not be the easiest value for us to use, because in the beginning, we could see 2 goes into both of these. So we could actually use any values that are equivalent to each other. So in this next example, we are going to convert 170 degrees to radians. So I'm going to multiply by a value that's equal to 1. Well, this time I'm going to simplify it. So instead of using 2 pi radians divided by 360 degrees, I am going to use pi radians over 180 degrees. Again, these two things are still equal to each other, so this works. We have our original value essentially being multiplied by 1, which means it doesn't really change. Now, when I multiply across, my degrees symbols are going to cancel, and I am going to have 170 radians over 180 radians, over 180, and this will simplify to 17 over 18 radians. We can't forget our pi value also. All right, so that's why it's important to write down our units as we go. We should have 170 pi radians. So that means our answer is 17 pi over 18 radians. So again, let's think about this. This is almost 180 degrees. Well, 180 degrees is pi radians. So that means when we convert this, our degrees should be very close to pi, and it actually is, right? Because 17 divided by 18 is very close to being 1, which means that this should check out. Now, the last thing I want to do is cover radians to degrees. So it's exactly the same idea, but now we want to get rid of the radians. So what that means is my radians is technically a unit. The unit will belong in our numerator for now. What I am going to do is put my radian measurement from our earlier fractions, and let's use this one because the values are a little bit smaller, in our denominator. So I am going to put pi radians down here, and then I'll put 180 degrees up top. And now our radians will cancel, the pi values will cancel, and we are left with 2 times 180, which is 360 degrees over 3, or 120 degrees. Okay? So I always like to try to compare this to where we think it would be on our unit circle. All right, 120 degrees should be roughly something like this, which means between pi over 2 and pi radians. Well, 2 pi over 3 is directly between there, so that's a perfect distance for us, and what that tells us is we're probably on the right track here, and in fact, we did do this conversion correct. So 2 pi over 3 radians is equivalent to 120 degrees. Now, last one here, exact same idea, 11 pi over 6 radians. I'm going to multiply by something that's basically 1. And since I want to cancel the radians, I'm going to put my radian measurement in my denominator. All right, and so we do this. We have 11 times 180, so let's cancel our pi's, cancel our radians. 11 over 180, 11 times 180 should equal 1,980 divided by 6, and we're talking about degrees. Now, if I divide those, and I just did this on my calculator, we get 330 degrees, which is almost 360, which would be a full circle. Well, that should make sense because 11 divided by 6, 11 pi divided by 6, almost gets us to 2 pi, and 2 pi is equivalent to 360. Okay, so that is kind of our introduction on the unit circle and radians. Just a quick recap for us. The unit circle is essentially a tool that we use so we can start to develop some understandings of sine, cosine, and tangent. All right, the unit circle itself is really just that inside circle of our origin, centered at our origin. All right, and this is what it looks like zoomed in. Now, we talked about radians, and radians is just a different way to measure the angle of anything, really. Okay, a full circle is 360 degrees. It is also 2 pi radians. Okay, so using that information, we're able to find some other angles, like 90 degrees here is equivalent to pi over 2 radians. 180 degrees here is equivalent to pi radians. And then we have 270 degrees is equivalent to 3 pi over 2. All right, so those quadrantal angles are really important. Those are the values that are directly in between our different quadrants. And that is kind of what we use to do our conversions down here. We're just using equivalent values. So really the first time I started with this one, all right, 360 is equal to 2 pi. But we got to remember that, the simplest values we can use are always going to be the best, so that's why I chose this one. Now, it wouldn't really make sense to use this because then I got to deal with some fractions in my radians, and that complicates things for us. Okay? So We have our conversions down here. To be honest, they're relatively straightforward. If you have any questions or concerns, as always, please feel free to reach out, and thank you for watching.